Hey everyone, welcome back to the channel. Now, if you have ever run MD simulations using Gromacs, you probably know how much time and patience it takes to get everything running smoothly. You begin by preparing your input files like MDP files, grow files, topl.top files, go on editing those files, so on and so forth. Now, if you are new to the system, this part alone can take a lot of time, like sorting through errors, fixing the paths, double checking the parameters. Well, it is a kind of tedious task. And once the system is finally ready, the real fun actually begins from there. You have to equilibrate the system in two stages, NVT and NPT, before you can even think about starting the production run. Now here's the problem. Doing these steps manually is a tedious task. You have to wait for each stage to finish before launching the next one, like run the NVT simulation, wait, then again run the NPT simulation, then wait again, and finally start the production run. In this way, it takes a lot of time management and manual efforts, especially when you are dealing with long simulation. So in my previous video, I have only conducted the NVT simulation and NPT simulation of 100 picosecond. Ideally, longer runs are required for setting up and running the actual MD simulation when you perform in real life. So it is advised that at least you should equilibrate for 1 nanosecond. In order to complete this tutorial in no time, I have only simulated till 100 picosecond, right? So every time you run the simulation, it is necessary that you edit this MDP file and change the number of steps and other parameters that will be sufficient for your MD simulation. So make sure that every time you run the simulation, just open it up and just check it out whether everything is fine or not. Well, this is the basic problem. So I thought, why not automate the entire process? Why not create a pipeline that will execute all the Gromacs commands sequentially, one after the other, without me having to sit around and stare at the monitor at every step that is running, right? So and that's exactly what I did. So what I did is that I wrote a simple batch script that you can see over here. I wrote this simple batch script that kind of creates a workflow and automates everything. So from TPR file creation to MD run execution for both equilibration and production runs are possible by executing this pipeline. So to use this automated pipeline, you might start out with the situation where you have already created the index file for ligand and your system in our protocol. So if you have directly landed up over here, then I would advise you that you view the previous video demonstration and see at what exact stage we are when I say that we should begin this automation at creating this indexing step. Okay, so once you have this automated pipeline with you, all you have to do is launch the script once and it take cares of the rest. No more waiting around between the stages for you. So in this video, I will walk you through how you can use this script for your own simulation. We will go step by step, setting up, running it, and making sure each stage completes successfully. So by the end of this tutorial, you will have your own automated Gromacs workflow. so you can focus more on science and less on typing repetitive command and scratching your head if something goes wrong, right? So if you find this useful, make sure to like, subscribe and share it with your fellow computational chemist, and drop the comment if you would like me to extend this automation for tools like NAMD or other open access softwares. So thanks for watching, and let's dive into the automation step. In order to run the Gromacs simulation in an automated mode, at least for equilibration and production, this is what you need to do. Of course, we are running it on Windows operating system, therefore we would just open the Gromacs command prompt, and we will now have to change the working directory. To change the working directory, we will have to first come into the C drive main folder, and then maybe paste our path here. Okay, now once you are in the right directory, let us make sure by giving this directory command, and now you can see that we have this file over here, pipeline.bat. I am talking about this file. Okay, so now all you have to do is to call this batch file from your command line Gromacs. And to do so, you have to only write the name of the batch file, like pipeline.bat, and when you hit the enter button, your automation will begin. As you can see, when I hit the execute button, the first thing that it did was it displayed this message. Now preparing the library input file .tpr required to start the NVT equilibration molecular dynamics run using GMX MD run, and then it kind of executed the grompp command that is first in line. And once this grompp command is finished, you can see this quote over here, Gromacs reminds you. This indicate that your TPR file has been successfully generated in the background. Then next thing that our script did was to execute the NVT equilibration simulation, and as you can see, then it initiated again the Gromacs in the background, right? And it initiated this Gromacs MD run, and now the 100 picosecond MD simulation run is going on. So in a similar way, after this 100 picosecond simulation is over, it will again create the TPR file for NPT stage, and then launch the 100 picosecond NPT simulation. After completing that 100 picosecond NPT simulation, it would again create the TPR file for your production run, and after creating that TPR file, it will launch the MD simulation for production stage as such. Okay, and once all the simulations are completed, at the end it will give you a message कि all simulations are completed successfully, press any button. So now I have initiated everything. I will stop my recording and get my lunch maybe, and let us see after few hours how is that the output looks like. So here we go, my friend. The pipeline just got executed, and it completed all the simulations in it successfully. So here is how your entire command line will look after successful completion of the pipeline. Like you can see over here, it created the TPR file, and once this TPR file has been created, here is where it started the Gromacs MD run for NPT. After NPT got finished, it again created the TPR file for production molecular dynamics run, and here you can see it successfully created the TPR file, and immediately it started running the production MD simulation using Gromacs MD run, and it took around 2 hours and 15 minutes. And once all the simulations are executed one after another sequentially and logically in this pipeline, it gives a message like all simulation completed successfully, and press any key to continue. So if I press this key, this Gromacs command line will close. So this is how things happen when you try to use this automated workflow. Now, if you work in a system that are based on Linux operating system, or if you are using a local cluster machine, or even if you are using cloud based facility that is provided by Indian government through national supercomputing mission, then such automation pipelines can be developed using shell script. But since in these demonstrations and set of videos that we are dealing with, we are focusing on Windows operating system, the same thing can be managed by creating the batch file instead of shell script. Well, now I will be uploading the pipeline file that I have demonstrated. I'm talking about this one. This pipeline file will be uploaded to the SourceForge website so that you all can use it on your end. And there you have it, my friends, a completely automated Gromacs workflow. From equilibration to final production run, everything is handled with just one command. This kind of automation not only saves time but also minimize manual errors. This will definitely be the plus point. I hope this demonstration gives you a clear idea of how you can build your own pipelines to make molecular dynamic simulation more efficient and reproducible. If you found this video helpful, consider subscribing the channel. I will be posting more tutorials on automating and optimizing MD simulation using Gromacs, NAMD and other tools as well. Thank you for watching, and I will see you in the next one.